Okay, so the last part of absolute values is the inequalities, at least for solving, that we're going to talk about today. So for absolute value inequalities, I'm going to take a look at this top section up here because I see the greater than and the less than, or less than, and then greater than or equal to message and the less than or equal to message. So in this area at the top, I'm going to actually graph this out. So I'm going to talk about specifically how to get these inequalities, but for now, I just want you guys to work through this with me. So when you have the absolute value of x is greater than or equal to 7, you can write this out as x is greater than or equal to 7, just like we have without the absolute value. And we can also write it as x is less than or equal to negative 7. This is kind of using what we did from equations, absolute value equations. We're kind of changing the sign that we had for our number. So we're kind of doing the same thing here, but it's inequality, so of course we have to flip a fraction or flip a sign. So from here, we're actually going to graph. So if I was to graph these two things on this number line, what would it look like? Well, we're going to have positive 7 is here. All of the numbers that are greater are to the right. And I have negative 7 over here. All of the numbers are going to be to the left. Those are the two answers, I guess it looks like, for this absolute value. How would I write this in interval notation, Chris? And at negative 7, what should you have? Okay, I know a union, but what type of bracket? There you go. Then a union. Go ahead. That's it. So I want you to make this note. Whenever you have the greater than or the greater than or equal to symbol, notice that Chris immediately said we need to write a union for this. Unions are the same thing as your or compound inequalities. We did this a while back. So when you see that union in the middle, that's like an or inequality from compound inequalities. Hopefully that helps. The last part for this is case 2. Okay, so we've already talked about the or union type of inequalities. Let's see what less than does. So we're going to do the same thing. We're going to say absolute value is less than or equal to 4. We're going to make this x is less than or equal to 4. Absolute value of x is less than or equal to 4. We're going to write it as x is less than or equal to 4 first. And we're also going to write x is greater than or equal to negative 4. So especially now that we have inequalities, we need to flip them, switch them if you want to say. It needs to be the opposite of what they currently are. And then you need to change the sign from positive to negative or vice versa. Just like we did before, take both of these and graph them on your number line. So we're going to start at 4. And it should be shaded to the left-hand side. And then we have negative 4. And we're going to be shading all the numbers that are greater, so to the right-hand side. What do you notice about both of these arrows? They're going towards each other. When that happened back at the beginning of the school year, what did we say happened? What type of answer would we usually write for these? Negative 4 to 4. What is that called? Begins with the I. Intersection. It's where both of the lines intersect. So I'm going to write that out. This is intersecting. And this is like the and inequality. We saw that at the beginning of the school year. So instead of putting both of those arrows in the middle, I'm actually just going to shade both of these with one solid line. So it's going to be just that space. So like you guys told me, it is going to be from negative 4 to positive 4. So that's the great thing about absolute value inequalities. So when it says on the far left over here, what does this mean? That means that your absolute value inequalities are technically compound inequalities 2. The reason why I'm saying they're compound inequalities 2 is because they have to deal with that intersection and union that we just talked about above. So we're going to see more than likely after we simplify, when we get that absolute value isolated, we're probably going to see intersections happen and unions happen when we graph these out. So I'm going to scroll down just a bit and we're going to look at these steps. So there's only 4 steps compared to the absolute value equations, and these steps are a lot nicer than the last one. So the first thing we have to do no matter what is isolate your absolute value expression. You have to do that right off the bat. The second thing you're going to do is create two cases. This is a little different from absolute value equations because we're now going to use what I call the KISS method. The KISS method says you're going to keep it and then switch, switch. So that means you're going to look at the signs. Keep it and then switch, switch. Just like we did last time, you're going to solve, and then you're going to graph your solutions and write your answer in interval notation. When I ask you for answers for this, guys, it's probably going to be asking you for interval notation. Sometimes on tests and quizzes, we might put like inequality notation, but I try to use interval notation as much as possible. But don't be surprised. Inequality notation might show up as well. So we're first going to look at number 1. So first question for number 1, is this one isolated, Michelle? Yes, the absolute value is isolated. So once I have that isolated, I'm going to focus on this inequality. This inequality, I'm going to highlight the inequality that I have here. Michelle, look at the top. This is the less than or equal to inequality. Is this going to be an intersection or a union whenever I graph this out? This is the less than or equal to inequality. What is this going to be? Intersection or union? So after you isolate, you can identify, is this going to be an intersection or a union? That also will help you check to see if you answered this correctly. We're now going to create two cases using the KISS method. Keep it, switch, switch. This is what I mean. We're going to keep the first one exactly the same. We're just removing the absolute value. And then for the second one, you have to keep the absolute value, whatever's inside, you have to keep that the same for sure. But the SS in KISS comes from switch the inequality symbol and switch the sign on your number. That's the only Algebra 2 part. The rest of this is Algebra 1. So right now, solve. I'm going to add 4 to each side here. And I'll divide both sides by 3. Wait a minute. When we divide, when do we flip the inequality symbol? What's negative? When the coefficient of x is, or the constant? The coefficient, whatever's next to x. If this coefficient is negative, that's when you flip this inequality. Since it's positive, though, I don't need to worry about it. And then for the other one, I'm going to add 4 to each side. So 3x is going to be greater than or equal to negative 4. I'm glad I asked. Desiree said I'm not going to switch the inequality unless this coefficient for x is negative. I don't care that the 4 is negative. I just care if the 3 is. So since it's not negative, I'm going to keep the same inequality symbol and write negative 4 over 3. Remember, we're not done. We have to graph and write the solution in interval notation. So over here to the side, I'm going to graph out a number line. It's not going to be the best looking, but it'll be close. I'm going to put 0 here. Negative 4/3 will be over here to the left of 0. Positive 4 will be somewhere over here. Just to double check, I know this should be an intersection, which means both of them should overlap, so let me double check. I'm going to have x is less than or equal to negative, or less than or equal to 4. So here's 4, less than or equal to. It's going to be this way. And then at 4 over 3, I'm going to do a closed circle. And it's now going to be going towards the other direction. Remember, intersection means you want them both to overlap. So you don't have to draw all of this out like I did. So notice that I'm just erasing the actual lines that I put in the middle, and I'm just going to connect it with one solid line. I just wanted to make sure, is this an intersection? Because that's what it said it was supposed to be. When you have intersections like this, how do we write our answer again? Okay, so just one and then the other. So we're going to put negative 4 over 3 with the bracket, and then positive 4 with another bracket. On tests and quizzes, guys, I'm definitely going to ask for the interval notation. However, I might also ask for your graph. So be prepared to graph things out, especially since it'll help you with identifying what you're supposed to be finding. All right, there's methods to my madness, guys. Let's look at number 8. So there's methods to my madness. Let's look at number 8. For question number 8, I do want you to make a minor little change really quick before you start solving this without me. Take a second, look at the board, because I already had somebody who didn't pay attention and wrote the wrong answer. For this inequality, this was greater than or equal to. Can you please change it to just greater than? So just make it a big greater than symbol, not greater than or equal to. So that way when you graph it out, you won't have closed circles. Either way, now that you have your inequality fixed, quote unquote, go ahead and solve question number 8. Do it from start to finish. So remember, the first and most important thing that you want to do is isolate the absolute value. So that means this negative 3x and this 2 have both got to go to the right-hand side. They have to move. There's no other way around it. So I'm going to move both at the same time. I'm going to add 3x to each side first. And I'm also going to subtract 2 on each side. So we're going to make this the absolute value of negative 2x plus 4 is going to be greater than, remember I changed this to the greater than symbol, not greater than or equal to. 6 minus 2 is going to give me 4. Negative 2 plus 3 is just positive x. Okay, do you guys agree? This is completely isolated, yes or no? Okay, good, it's completely isolated. I'm going to take this inequality and I'm going to make a little note. This inequality means that it's the greater than symbol. I'm going to flip back over to the first page really quick. Greater than symbol means that I need to write this as a union. So there's going to be two things going in two separate directions. So this should be a union. Okay, well with that in mind, I'm going to continue to solve. I'm going to create two cases using the KISS method. Inside of that absolute value, it has to stay the exact same. There's no excuses. Has to stay the exact same. I'm going to keep it greater than 4 plus x for the first one. And for the second one, I'm now going to make it less than negative 4 plus x. Make sure you look at the board. I'm not just putting negative 4 and then an x. I'm putting negative 4 or negative parentheses 4 plus x. Notice that it's in parentheses. From here, you're going to solve. So I'm going to subtract x on each side. I like to get my variables on the left. Hopefully you guys too. Because when you're writing it as an inequality, it's easier to graph that way. So we're going to have negative 3x is greater than 0. You're not done. You still need to get x by itself. To get x by itself, we're going to divide both sides by negative 3. X is going to be, wait, should I put greater than or less than? Less than. Why less than? Because I divided by a negative. So x is less than 0. That's the first one. And then for the second one, we have to distribute. So we're going to make this negative 2x plus 4 is less than negative 4 minus x. I'm going to add x to each side. And then I'll subtract 4 on each side. Do these cancel? They do? No, they don't. They become negative 8. So negative x is less than negative 8. And then just like we did before, we have to divide both sides by a negative. So x is now going to be greater than 8. All right, let me zoom out since I actually want to zoom out. I'm going to graph this on a number line. Here's 0, here's 8. Remember, I've changed this to the less than symbol, so that means you're not going to include these with the closed circle. X is going to be at 0. It's going to shade to the left-hand side. X is going to be greater than 8. I'm going to put an open circle at 8 and shade to the right. Tristan, how would I write this in interval notation?
This is
Negative 8?
negative.
Okay, good. Negative infinity. I was like, woo. Okay, go ahead.
0 bracket.
Bracket or parentheses?
Oh,
Parentheses. It's okay. Union. Go ahead to the other side.
8.
2. There we go. Be careful. Remember, for this one, guys, I changed it to the less or the greater than symbol just because I wanted to show you guys how to write your answer in interval notation using that information. All right, let's look at the next two, which are going to be 4 and 5. So let's look at numbers 4 and 5. You can definitely try these out before me. So if you want to flip it over, try these out before I get to it. Good, do it. Numbers 4 and 5. So we're going to subtract 4 on each side. We're going to have the absolute value of 5x plus 6 is less than negative 3. Wait a minute, we did this before. Whenever we have an absolute value, especially with some kind of negative, if I take the absolute value of some number, it's never going to be a negative number when I actually take the absolute value. So when you get to this point, you can actually stop. The reason why, let me actually erase that really quick. We're actually going to stop right here. The reason why is because we have a negative number. Okay, well, with that negative number, let me come back here and see what I'm going to put. There's two things we can either write. We can either write no solution or all real numbers. For this question, this is actually a no solution. And here's why. It's no solution for this answer. I'm going to highlight this in yellow really quick. The reason why it's a no solution is if you have the absolute value of x being greater than some negative number, or if you have absolute value of x being greater than or equal to some negative number, it's always going to give you a no solution every single time. So if you have absolute value of negative x is less than some negative number, or if you have the absolute value of some number is, or some variable x is less than or equal to some negative number, it's just going to be a no solution. All right, so for the last one, for number 5, same thing. I'm going to subtract 9 on each side. So we're going to have the absolute value of 3x minus 4 is going to be greater than negative 4. Okay, we have the same issue. With this problem, I have a negative 4. You can't, even though I know you can try to create two cases and solve, I'm telling you now, once you get to that negative, you need to stop. You cannot continue to solve. Is this going to be a no solution? Why not? The greater, thank you, the greater than symbol. So when we have the greater than symbol, that's not the same as what we had here. So I'm going to highlight this. That inequality symbol is going to help you with determining if something is a no solution or if it's like here where it's a all real numbers. For this all real numbers, this only occurs when it's the greater than or equal to symbol. So if it's the absolute value of x is greater than some negative number, or if it's the absolute value of x is greater than or equal to some negative number. That's the only times you're going to use all real numbers. Okay, so we've looked at one example of intersection, one intersection of union, and we just saw two examples of what a no solution looks like and what an all real number solution looks like. So what I want you guys to do right now is flip it over to question number 7. And I want you guys to try this one completely from start to finish. We'll give you about 2 minutes. After you finish this question, I'm just going to post the answer. So go ahead and do this question. You have 2 minutes. So for question 7, your answer should be 3 and 7, both of these with brackets. I always feel weird about like not going through it, so I'm actually just going to go through this with you. It literally will take like a couple of minutes. So the first thing you should have done was added 2. We're going to have 3 times the absolute value of 5 minus x is going to be less than or equal to 6. I'm going to divide both sides by 3. So we will have the absolute value of 5 minus x, I'm going to make this a darker absolute value, is less than or equal to, not 3, but 2. When you get to this isolated inequality, that's what you need to look at to determine, is this an intersection or union, and is there anything else that I need to do? Can I split this into 2 cases? So if I look at this, first of all, I do notice that this is positive. Okay, perfect. That means that I can definitely create 2 cases, unlike the last question. I also know, based on this inequality, that this is going to represent an intersection. Since it's the less than or equal to inequality, this is going to represent an intersection. So I need to see, when I graph it, where both of the lines are going to overlap. So from here, I'm going to zoom in just a bit, and I'm going to create my 2 cases. We're going to have 5 minus x, if I can actually write this nicely. 5 minus x is going to be less than or equal to 2, and 5 minus x is greater than or equal to negative 2. So we're going to solve. Excuse the horrible handwriting, by the way. I'm going to subtract 5 on each side. So we'll have negative x is less than or equal to negative 3. And then especially since this negative is in front of x, I need to divide both sides by negative 1. So x will be greater than or equal to positive 3. So that's my first answer. I need to do the same thing for the other side. So we're going to subtract 5 on each side. This time it'll become negative x is greater than or equal to negative 7. And then I'll divide both sides by negative 1. For this problem, x will be less than or equal to positive 7. Notice that the signs flip. Because you divided by that negative, they are going to flip, switch, however you want to say it. They're going to be pretty much the opposite of what they were originally. This was originally a less than or equal to. It's now greater than or equal to. This was greater than or equal to originally. It's now less than or equal to. That step of dividing and switching your sign is super important because it helps you determine if it is supposed to be an intersection, does it actually create an intersection when you solve it? If you're like, oh, that flipping doesn't really make any sense, I'm not going to do it, you're going to mess up on your answer. If this is an intersection, when I graph both of these, I should see both of those lines overlap. So over here to the side, I'm going to graph this out. So we're going to have 3 and 7. Okay, so x is going to be greater than or equal to 3, so we're going to shade this way. And x is going to be less than or equal to 7, which means it's going to be shading this way. Yep, they both overlap. So I'm just going to re-graph that to make it a little nicer. Just going to make it all of that. That is how I got 3 to 7. And that's a bracket over here. This is a bracket. Okay, for funsies, let's go ahead and flip it over to the very last page of this packet. And I like even numbers, so let's go ahead and do question number 10. Question number 10. Okay, so we are back at equations, which is fine, but this one now has 2 absolute values. When you see questions that look like this, I'm giving you a heads up. You are potentially going to have 4 different cases. 4 different cases mean you're going to have to do the absolute value twice. Let me show you what I mean. So first things first, as of right now, with what you have, you're going to need to move either this absolute value or this absolute value to the other side of your equation. It doesn't really matter which one. I usually just take whatever's closest to my equal sign and I just move that. So I'm going to subtract the absolute value of x minus 3 on each side. So we're going to have the absolute value of x minus 2 is going to equal 1 minus the absolute value of x minus 3. Okay, so from here, you are going to need to create 2 cases from this equation. All right, so let me write this out. I'm going to kind of draw one all the way over here and one over here. Yeah. Okay, so on the left, we're going to have, for this absolute value, we're going to rewrite it as x minus 2. it's going to be gone from the absolute value or symbol, is going to equal 1 minus the absolute value of x minus 3. Pretty easy, right? We're going to do the same thing for the other side. For the other side, though, we're going to keep the x minus 2 the same, just like we saw before. But now we need to make all of this negative. So negative parentheses, 1 minus absolute value of x minus 3. Okay, well, let's think about it. Don't overthink it. Don't stress yourself out. On the far left-hand side, we can easily simplify this. On the far right-hand side, we're going to have to distribute that negative. So this is what I always tell my students to do. Focus on one side of your problem that you want to work on. So I'm just going to draw a little border down the middle. I'm going to focus on this side over here, the far left-hand side. I'm going to solve all of this first, and then I'll go to the other side. So I'll tell you now, pack your patience, guys, because we are solving the other side. Okay, so for this question, let me think. How am I going to solve this? Okay, well, let's do a couple things. Let's move this 1 to the other side. So we're going to subtract 1 on each side. This is going to leave me with x minus 1, excuse me, not x minus 1, x minus 3 is going to equal the absolute value, negative absolute value of x minus 3. Okay, I need to get rid of that negative 1 because remember, you want to completely isolate your absolute value. We're going to divide both sides by negative 1. So notice that everything is being divided by that negative. We're going to make this negative x plus 3 is going to equal the positive absolute value of x minus 3. Nothing inside the absolute value is affected by this negative or anything else that's being moved. Nothing's being affected inside the absolute value. Once you get to this step, you should know exactly what to do, guys. You've done this pretty much all day. We're going to make this into 2 separate cases. The first case is negative x plus 3 is going to equal the regular x minus 3 that's in that absolute value. And then we're going to have this negative x plus 3 that we now need to make negative. And we're going to set that equal to x minus 3. This is what we're solving. So for the first part on the far left, I'm going to kind of draw another line here. On the far left, I'm just going to add 3 to each side. So we'll have negative x plus 6 is going to equal x. And then I'll add x to each side. So it looks like we're going to have 6 equals to 2x. And when you divide both sides by 2, 3 will equal x. Now we need to do the same thing over here. So we need to first distribute. So we're going to make this positive x minus 3 will equal positive x minus 3. Think back to Algebra 1. This looks like a specific type of answer we've seen before. It's okay if you don't remember. I'm going to go ahead and subtract x on each side, and you should see it now. Both of the x's cancel. They're gone. So I'm just left with negative 3 is equal to negative 3. That's it. So for this second answer over here, I don't need to do anything else. There is no other. Please do not write x equals negative 3. That's not an answer. The x's are gone. When the x's are gone, you don't need to continue any further. You're done with the far left-hand side of this equation. Okay, so we have pretty much nothing on this side that we need to check. This side, we are going to need to check x equals 3, but we'll wait until the end. So let me at least go through the other side, and then we can come back and check to see if x equals 3 is in fact going to be a solution or if it'll be extraneous. Okay, so I'm going to zoom out, and I'm going to look at the right-hand side. Okay, we're going to do the same process that we just did on the last question. So first thing I need to do is distribute that negative. Ooh, let me actually erase that really quick and just show you that I'm distributing right to here. I'm just changing the sign for the negative that's in front. I'm not changing anything that's in this absolute value. It's a no-touch zone. Don't touch anything in here. So when I write this out, we're going to have x minus 2 is going to equal negative 1 plus absolute value of x minus 3. You cannot touch anything that's in this absolute value until you split it into the 2 cases. Okay, so I'm going to add 1 to each side. So we'll have x minus 1 is going to equal absolute value of x minus 3. Luckily for us, there's no negative in front of the absolute value anymore, so I just really need to create 2 cases, just like we did on the other side. So over here to the side, I'm going to create x minus 1 will equal just the regular x minus 3, no longer in the absolute value. And we're also going to have x minus 1 will equal negative, oops, let me actually write this correctly. Negative x minus 1 will equal x minus 3. Whatever side your absolute value is on, that's the one that you're just going to literally copy and paste. The opposite side, that's the one you have to make one positive and one negative. So we're going to solve. I'm going to subtract x on each side. Ooh, and when I do that, both of these cancels. So by having negative 1 equal to negative 3, I can't do anything else with that. That part's done. I do, however, need to continue to solve the right-hand side. So negative x plus 1 is going to equal x minus 3. I'm going to subtract x on each side. That's negative 2x. Be careful. And then I'll subtract 1 on each side. So negative 2x will equal negative 4. I'm going to divide both sides by negative 2. So x will equal 2. So let's take a second and look at everything. Okay, here's all the stuff that we did. We created from the original problem. We had to move so that way you had one absolute value equal to another absolute value like we see here. And we had to split this into two cases. We did that in gray. Once we had both of those cases, we had to further separate it into two more cases. So once we separated them, we simplified like we did here. And when I said we simplified it into two more cases or split into two more cases, that's these two cases here when we did this and this. Same thing on the far right-hand side. Once we rewrote our simplified case, we're now going to create two additional cases. By the end of this, guys, you should have no more. And if you look at this, this, and this, there's no more absolute value. There's none left. That's what you're trying to get to. So you're going to have to keep splitting it into two cases, over two cases, over two cases, until you just have no more absolute value. And it's just an equation. That's what you're getting at. So I've solved everything. I need to confirm if 3 and positive 2 are going to be a solution for the original problem. So let's double check. So over here to the side, I'm going to do this in red for my check step. We're going to take the absolute value of x, which I'll do the first one is 3, minus 2, plus 3, minus 3, should equal 1. Okay, let's hope it does. 3 minus 2 is just 1. 3 minus 3 is 0. Be careful. Does this mean that it's undefined? No, it just means that it's 0. So we really just have absolute value of 1 plus the absolute value of 0, which should equal 1. Well, 1 plus 0 is just 1. So that means x equals 3 over here is a solution. That's a solution. Let's double check too. So we're going to have the absolute value of 2 minus 2 plus the absolute value of 2 minus 3, and that should equal a positive 1. 2 minus 2 is 0. 2 minus 3 is negative 1, and that should equal just 1. We've already talked about this. The absolute value of 0 is okay. It's okay to have the absolute value of 0. We're just going to write this as 0 plus the absolute value of negative 1, which is just positive, should equal 1. 0 plus 1 is in fact 1. So that means down here at x equals 2, that is my other solution. Remember, we're back at equations. We're not graphing any inequalities here. We're just just solving the equation. No graphing. That's why I had to go back to check for extraneous solutions. For question number 10, I don't want to automatically say I'll give you a question like this, but it's a possibility, especially now that I've gone through it. So especially with question number 9 that's right above it, use that as a practice question to help you hone in on this skill. If you have any questions, make sure you let me know.